Welcome to Mark's Tech Talk. In this edition, we're going to examine mesh analysis. What exactly is mesh analysis? Is a tool for analyzing circuits. Some of you may have already encountered something called superposition. This is an alternative to that, a different way of analyzing circuits, but it's actually more powerful than superposition because it can be used on more circuits, including circuits that are not traditional series parallel circuits. The only limitation on mesh analysis is that the circuit must be planar. And what that means is that you can draw a schematic of the circuit without any crossovers. So let's take a look at what do we do. Well, first of all, in order to understand mesh analysis, you have to say what is a mesh. And a mesh is simply a loop being a path in which current can flow around a circuit. But it's a particular kind of loop. It's a loop that does not contain any additional loops. So if we look at the circuit shown on the bottom here, we'll look at a couple different loops and meshes here. So if we look at the portion of the circuit around the outside perimeter, the part colored in blue, that is a loop. However, it is not a mesh because there are other loops inside of that. If we look here, you can see that's another loop. This, again, blue outline represents a loop. It's also a mesh because there are no loops inside of it. Here is another variation. This is a loop. However, it is not a mesh because there are loops within this. So that should give you some idea of what a mesh is. So when we go to analyze a circuit, what we're going to do is assign currents for each mesh. We're going to assume the current is flowing around the mesh, and we usually assume a clockwise direction. And once we assign those currents to each mesh, then we write a Kirchhoff's voltage law equation for each mesh. Remember, some of the voltage drops around the loop or mesh is going to equal 0. For each mesh, we'll get one equation, so we'll have several equations. When we have several equations like this, it's called simultaneous equations or systems of equations. And there are several different methods of solving systems of equations, including substitution, elimination, and several others. I suggest we simply use a scientific calculator. I am not going to go into details on how to utilize a calculator because there are too many different various brands of calculators that all do it a little different. In this case, I would say Google is your friend. Just Google the model number of your calculator along with systems of equations, and I'm sure you'll find some explanation of how to solve it on your particular calculator, and many times that would be a YouTube format. So I'll let you explore that. We're just going to look at the circuit theory behind this. So let's say we have a circuit like this, 3 resistors and 2 sources, and we're looking for I3. That would be the current in R3, the one right in the center of the circuit. So for mesh analysis, what we do is assign our mesh currents. So there is I1, that is a current that we're going to assume is flowing clockwise through that mesh. And this is kind of an imaginary current that will allow us to solve for what we're actually looking for, which is the current through R3. We'll do the same thing with the next mesh. We'll call this one I2. And then we start writing our equations. Again, reminder to do that, it's good to assign polarities. So when the current enters a resistor, we'll call that the positive terminal. And that will assist us in writing our KVL equations. So reminder, just put in the back of your mind, we're looking for the current through R3 for this circuit. If you look at the mesh currents that we kind of imagined, I1 is flowing through R3, but so is I2, and they're flowing in opposite directions. So I3 would be I1 minus I2, okay? All right, so getting down to the equations, we start with the first mesh on the left-hand side, and just for habit, so we always do it the same way, we generally start in the lower left-hand corner. And as we move around the loop, we see I have a 15-volt source there. Goes from negative to positive, so that will be a positive voltage. The voltage is increasing. And then we have the voltage across the resistor. We can get that voltage using Ohm's law. it would be the value of the resistor 1K times the current flowing through it, which we assume to be I1. So that voltage is 1K times I1. The current is entering on the left-hand side, so that's positive. Going around the loop, we're going from positive to negative, so we're decreasing the voltage. So we call that a minus 1K I1. Moving further around the loop, we encounter R3. Again, our current is entering there, so it's a positive on top. So we're going from positive to negative. It would be a negative. The resistance value is 3K. And then the current through that resistor is I1 minus I2. And that brings us to the beginning again, so we say equals 0. Now we repeat that process for the right-hand mesh. Again, doing KVL starting in the lower left-hand corner, we have 3K times the difference between I1 and I2, but because we're doing the second mesh, we looked at I2 first and said I2 is entering the resistor. That would be a positive terminal. We're going positive to negative, so that would be a negative value for the voltage. And that voltage would be the resistance, 3K, times that current, I2 minus I1. And then the next one we have is the 2K resistor. That voltage is 2K times I2. Again, that would be a negative. And then we come to the voltage source there. We're going from positive to negative, so it's a negative 30. And we're back to where we began, and we get equals 0. Notice when we're doing these mesh equations, the first equation with that common resistor, we said the current is I1 minus I2, because that's the way we assign the polarity markings. When we did the second equation, we assigned the polarity markings based upon I2, so we say it's I2 minus I1. Once you have those equations, then you just have to collect your terms and rearrange those, so I1 is first and I2 is second, and your constants are on the right-hand side. So collecting the I1 terms, we have a minus 1K and a minus 3K. It gives us a minus 4K I1. And then the I2 is a minus 3K and a minus I2. That gives us a positive 3K I2. Moving the 15 to the other side of the equals gives us a negative 15. Do the same process for the second equation, and we get that. Now we can use those coefficients and enter them in our calculator in order to get I1 and I2. And this is where you want to use Google to find out how to utilize that in your particular model calculator. And you should get these answers when you do that. I1 is a negative 1.36 and I2 is a negative 6.82, and both of those are in milliamps. And what we're really looking for here is the current through R3, which we said would be I1 minus I2. So just to recap here, I1 is flowing down through R3 and I2 is flowing up there. So we're looking for the difference between those to be that current. So IR3 is I1 minus I2, which gives us 5.46 milliamps. 5.46 milliamps. Let's look at another example. Let's say we're looking for the current in the load resistor, which is the 40K in this example. We're going to again utilize mesh currents to do that. So we assign a first mesh current on the left-hand side, I1, and the second one on the right-hand side, I2. Assign your polarities and work your way around the loop writing your KVL equations. And what we have is 12 for the source. The voltage drop across the 10K is 10K times I1. That would be a negative because we're entering the positive terminal. And then we have a minus 20K, I1 minus I2, opposite directions. We got the polarity from I1. And then minus 18, from positive to negative, that would be a minus 18. Back to where we began, equals 0. And then the second equation, that's going around the second loop. We start out with the 18 source. This time we're going from negative to positive, so it's a plus 18. Now we have the polarity based upon I2, so we say minus 20K I2 minus I1 minus 40K I2, and we're back to where we began. So again, we're going to collect the terms, and make sure when you collect the terms you have the I1 terms first and the I2 second, and so forth. So when I did that, I got negative 30K I1 plus 20K I2 is equal to 6, and the second equation is 20K I1 minus 60K I2 is equal to minus 18. When I plug that in my calculator, I got 0 for I1, and I got 0.3 of a milliamp for I2, and I2 happens to equal the current we're looking for, the current through that load resistor. So at this point, we're done. All right, one more example here. We have a 5-volt source and a 20-volt source. Again, we're going to assign our mesh currents. Usually I do I1 on the left and work my way left to right. And so I'll do that. I1 is there, I2 is there, okay, and add my polarity markings. And just write down our Kirchhoff's voltage law equations. So for the first loop, I have 5 minus 5K I1 minus 5K I1 minus I2. That's for the resistor 2. And then we're back to where we started, so we say equals 0. For the second loop, we start out with that R2, so we have minus 5K I2 minus I1. Now R3 is a minus 5K I2, and then minus 20 is equal to 0. Again, we're going to collect terms and rearrange, and we get negative 10K I1 plus 5K I2 is equal to negative 5. Second equation, 5K I1 is equal to negative 10, should be 10K there, I2, is equal to 20. And that would give us a negative 2/3 of a milliamp for I1 and negative 2 1/3 milliamp for I2. And again, notice there is one little typo there. That should be 10K I2. All right, let's try one with 3 meshes in it. So I'm going to assume that is I1, okay, and I'm going to make that one I2, and then on the bottom right, I'll make that I3. I add my polarity markings, and now when I write my equations, I'm actually going to have to do 3 equations. There's 3 meshes, so I'll get 3 equations and 3 unknowns. First equation is 20 minus 2K I1 minus 3K I1 minus I2 minus 4K I1 minus I3. Notice that's a different one, I1 minus I3 there. And then we're back to where we started. The second equation will go around the second loop there. Starting in the lower left, we have minus 3K I2 minus I1 minus 6K I2. And then notice the current in the 5K, the minus 5K, I2 minus I3. Got to really pay attention to currents when you have more than 2 loops here. All right, for the third loop, we have minus 4K I3 minus I1, minus 5K I3 minus I2, and then minus 7K I3. Gives us these equations. We collect our terms, and we wind up with these 3 equations. And again, with a calculator, that is not that terribly difficult to solve. We just put the coefficients in the calculator, and you're going to get I1 is 3.42 milliamps, I2 1.34 milliamps, and I3 1.69 milliamps. So that's an introduction to mesh currents, and hopefully that will put you on your way to solving some problems that perhaps you weren't able to solve before. Hope you enjoyed it, and thank you for watching Mark's Tech Talk.